Conformational isomerism. We are going to talk about the conformations of normal butane today. The conformational is due to rotation around carbon-carbon single bond, and our focus points for today's class is our learning objectives. They are going to be, number one, we are going to interpret, we are going to draw, and we are going to see the rotation about carbon-carbon single bond using Newman projections. Sawhorse projections we are not going to consider over here in detail, but we will talk about Newman projections. And secondly, we will also correlate the energies of all the conformations of butane with rotational energy diagrams, and we are going to predict which one is the most stable conformations of butane. So let's go on to butane first. When we're talking of butane, it is considered as a dimethyl derivative of ethane. So let's look at the structure. The structure over here which we have is butane is a dimethyl derivative of ethane. We are going to consider the rotations between carbon atom 2 and 3 and the angle between carbon atom 1 and 4. That is the angle between two methyl groups. That is known as the dihedral angle, and it is represented by theta. Okay, so we are going to do the rotation around carbon atom 2 and 3. We are going to correlate the energies. We are going to look at the 6 conformations. Although there are a lot of conformations which are formed, the 6 conformations, they are the most important and the most common conformations of butane. Now, let's consider butane. As I've already told you that it's a 4-carbon chain. So we have 1, 2, 3 and 4, CH3, and we have H, and we have H. Here also H, and we have CH3. So we will only focus on to the rotation between carbon atom number 2 and 3, keeping carbon atom number 1 and 4 as the substituent of carbon 2 and 3. Right? And that is how we are going to discuss about the dihedral rotation and how the rotation by 60 degrees is going to affect the energies in all the conformations. So this is the first one which we have. I'm looking at the Newman projection over here. This is the Newman projection which we are taking, which can be represented by 2 carbon atoms, 1 carbon atom which you can see in blue color, and the other one is a bigger cycle which you can see in white color. So to each carbon atom, there are 2 hydrogens attached and there is a methyl group is attached, and we are going to rotate the blue carbon atom, keeping the red carbon atom fixed, right? So over here, in this form, as you can see that the methyl groups, they are in line with each other. This is known as the eclipsed form. This is one of the most common form which we are going to study in our class today. So this is the eclipsed form in which the 2 methyl groups, they are in line with one another, and the value of theta, that is the dihedral angle, in this case is going to be 0 degrees Celsius, right? As they're in line with one another, so the angle that is going to be 0 degrees Celsius. Then we are going to rotate the first one by 60 degrees. You can see we are rotating the blue one by 60 degrees over here, and the angle, the dihedral angle over here, that is 60. So we can well point out that theta in this case is going to be 60. So this form, this is known as the staggered form. Of course, they are going to be given different names as we keep going further, but over here, the methyl groups, they are further apart from each other. Therefore, this is known as the staggered form. So this is the staggered conformation which we have. Two conformations which are most important. The first one is your eclipsed and the second one is your staggered, and rest of them are going to be distributaries as we are going to keep rotating it by 60 degrees. So let's look at the distributaries, or you can say let's look at the middle conformations which we have. So now we are rotating it further by 60 degrees. In this conformation, you can see that hydrogen and methyl group, they are in line with each other. So this is known as partially eclipsed form. This is called partially eclipsed. When both the methyl, they are in line with one another, that is completely eclipsed form, or it is normally known as eclipsed. When the methyl and hydrogen, they are in line with one another, they are known as, that is known as partially eclipsed form. So this is going to be partially eclipsed form. The value of theta over here, that is 120 degrees, right? So the dihedral angle over here is going to be 120 degrees now. Now, if we are taking another 60-degree rotation, the conformation that is known as anti-conformation, and over here the methyl groups, they are positioned opposite to each other. The value of theta in this case is 180, and this is known as the anti form or the anti-conformation, as the methyl forms, they are opposite to each other, right? So this is the anti-conformation which we have. So let's look at a complete summary of what we are doing. And I have 6 conformations or 6 structures, 6 different structures of butane over here by taking a rotation of 60 degrees as we are moving from one structure to the other. Here, this is the first one is the eclipsed form. The value of theta as already taken, that is going to be 0 degrees Celsius. CH3 in line with one another, eclipsed conformation. This is the most unstable conformation of all the conformations which we are going to study. The reason being that the two bulkier groups or the same groups, they are closer to each other, thereby causing maximum repulsion. These are going to cause maximum repulsion, as a result of which their potential energy is going to be higher, and therefore this is the most unstable form. So let's take a rotation by 60 degrees now. We've rotated by 60 degrees. The value of the dihedral angle over here is going to be 60. This is known as the gauche conformation, and this is a part of the staggered conformation where the groups, they are far apart from each other. They are not in line with each other. So they are further apart from each other. Therefore, this is a part of, or we can say this is a form of staggered conformation. Again, theta 60 degrees, we are giving a rotation again by 60 degrees. So theta in this case now, that becomes equal to 120 degrees, the dihedral angle, and methyl and hydrogen, they are in line with one another. This form is known as the partially eclipsed form. Now, this is, of course, more stable than the first structure which we have seen over here, which is a fully eclipsed. So, the partially eclipsed is going to be more stable than the fully eclipsed. Another rotation we are going to take over here, theta in this case is 180 degrees. The fourth structure, in which the methyl groups, they are directed opposite to one another. This is the anti or anti-conformation, which has the maximum, this is the most stable structure with minimum energy. As the bulkier groups or the similar groups, they are opposite to each other. So repulsion is going to be minimum and stability in this case is going to be maximum. We are taking another rotation. So we go on to theta, which is equal to 240 degrees. This is again an eclipsed rotation, which is similar to your structure 3. So if you're looking at structure 3 and you're looking at structure 5, both seem to be mirror images of each other. So this is also a partially eclipsed conformation. This is also a partially eclipsed conformation. It is going to be more stable than the eclipsed conformation. Another rotation of theta we are taking over here. So theta in this case is going to be 300 degrees. 300 degrees gives us a conformation which is a gauche. Again, if you're looking at the second structure and you're looking at the sixth structure, they seem to be quite similar, and we can say that they are also mirror images of each other. So the gauche conformation, in this, the methyl groups, they are slightly closer to each other, but this is a form of staggered conformation which we are studying. So this is more stable than the eclipsed conformation. Let's try and analyze the energy differences between all of these by taking a graphical representation over here. So this is how our energy analysis can be done. The first structure we are talking of, this is the first structure, which is the eclipsed structure which you had done. In this case, you can see that the potential energy is maximum and the stability is going to be minimum. So this is a graphical representation of valley and peaks. At the valley, the structure is going to be at a lower energy. At the peak, the structure is going to be at a higher energy. All the structures which are at the valley, they are more stable than the structures which are on the peak. So if you're looking at the one which has the lowest energy, that is going to be the NT structure, in which the methyl groups, they are directed opposite to each other. And you can see the energy differences or compare the energy differences of NT and the other structures. Let's try to do that. If we're talking of the energy difference between the eclipsed form which we have taken over here, right, and the NT, the energy difference is 3.6 kilocalories. Same is the case over here. As you can see that this structure and this structure, both these structures, they are mirror images of each other, and therefore the energy difference between the NT and the eclipsed, the partially eclipsed form which we are taking over here, this is going to be again 3.6 kilocalories. The next energy difference which we can take over here is between the gauche form and the NT form. Between the gauche form and the NT form, the energy difference is not too large. It is only 0.88 kilocalories, in which the methyl groups, they are slightly closer to each other. So this is the staggered form which we are taking. But the maximum energy difference is between the NT periplanar structure and the syn periplanar structure. Syn means on the same side, NT means on the opposite side. So over here, the fully eclipsed and the NT, they are going to have an energy difference of 5 kilocalories per mole. Now, if we are looking at the order of stability of all the structures over here, let's try and figure out the order of stability, guys. The order of stability over here is going to be, in the first case, we are saying the most stable is going to be the NT, which is at the lowest energy. NT planar, which is at the lowest energy. This is going to be the most stable. And then after NT, which is at the lowest energy, we go on to the next one. The next one is going to be gauche. After NT, the gauche, that is going to be more stable. And then after gauche, it is going to be partially eclipsed. After partially eclipsed, that is going to be fully eclipsed. So the syn periplanar structures which are at the top of the peak, they are going to be, so this one, the syn periplanar over here and the syn periplanar over here, both of these, they are going to be the most unstable structures, and NT is going to be most stable. And then we have the energy difference of 0.88 kilocalories between the NT and the gauche. So gauche, that is going to be less stable than NT, right? So gauche, you can say that it is going to come in the middle of both.